Okay, so to introduce myself, I'm Glenn Jocker. I got into AI about 4 years ago, but before that, I was doing particle physics, and that's how I started Ultralytics, which is my startup now. So in 2014, I was doing anti-neutrino detection for U.S. intelligence agencies. Seems like a weird match, but ultimately they were interested in studying these particles that kind of monitor reactors from afar. So I got into it for the data analysis part. I wasn't really a particle physicist. I sort of had to kind of learn as I went along. And uh, what I realized was that a lot of the data analysis that we were doing there had parallels with what was going on in the vision AI space. So about 5 years ago, 6 years ago, this looked like, for example, you go to Google Photos and suddenly it'd be searchable. You could type in dog and a picture of a dog would come up. And I thought this was really, really interesting. And I realized in our particle physics, we had the same challenge. We'd get some detections and we had to figure out if it was, say, like a neutrino or an electron, a proton, because we were really just interested in one kind of thing. So we're doing classification using traditional techniques. And it wasn't going very well. And our program was been the threat of being shut down. And so I got a little bit desperate and I started researching ML, looking at books, trying to figure out what's going on and how it could help and produce better results for these programs. And ultimately, it was all for nothing. The effort collapsed and we lost all our jobs. And I think a big part of that on the ML side was because I didn't have real data. I had simulated data. And in physics, in some places, like we're not too confident about what really happens. And so the simulations may have not been identical to the real world. And so we see that similar parallels these days. It's always a question of whether you want to try and simulated or real data. They both have advantages and disadvantages. But ultimately, since I'd lost my government contracts, I had more free time. And this is a great chance for me to really catch up on what was going on in the vision space. And this was exciting times. There was a guy called Joseph Redman, and he had launched the first three versions of YOLO. And they were faster at detecting objects and images, mostly because of one key difference, and that they just went through an image one time instead of first spotting objects and then coming back to classify them. And so this is a great chance for me to kind of learn how he was doing it, and more importantly, port that over to something that I could actually use, because he did all his work in C in a framework called Darknet, which was very impressive because he had to write his own back propagations, optimizers, almost everything. It's very, very impressive, but also hard to reproduce. So if you're new to the space and you want to get in the latest and greatest YOLO models, you had to get your hands dirty with Darknet, which is very tough. So I started doing a few new things that I'd never done before in my life. First of all, I started open sourcing all my work. And this is really exciting and kind of scary. When I worked for the government, they didn't like that. So this is the first time that I could actually write something and someone could just run off with it. And I wasn't sure what would happen. I was always kind of like worried that I'd make something cool and people would just copy it, which is what happened. But it turned out to be actually wonderful because all those people contributed back. So I started open sourcing everything. I started using Python for the first time. I'd been up to MATLAB only until then. And I also had a big decision to make between Torch and TensorFlow. I did a bit of research, and Torch seemed more Pythonic, which to me was more MATLAB-like, and I went with that. And I think all these things were the right decision. I started trying to port YOLOv3, which was state of the art at the time, into PyTorch. And the most important thing to me was to make it very easy, very simple to use, and make it applicable in the real world. Because in my particle physics days, I've seen a lot of research programs, cool stuff in the lab, but ultimately, to me, it didn't leave me satisfied unless it was actually in people's hands and making a difference in their lives today. So that's really what I wanted. So as I worked on YOLO, I made a lot of mistakes. Initially, I had no idea what I was doing, and a lot of people pitched in to help, and it ultimately started improving and improving. And while I was doing this, something interesting happened. Joseph's work had got so popular that he'd gotten to invites for a lot of TED Talks. At one of them, he was approached by the military in the US, and they wanted to use YOLO for military applications, mostly drone imagery, detecting people, and making it more efficient to drop bombs on them. And so he got really scared. He said, I don't want my work used for this. And he sort of recused himself from further research and development with YOLO. So he had an academic advisor also that they worked together with called Ollie Farhadi. Ollie started a startup called Xnor, and he sold it to Apple for a bunch of money, and he's still there today. So this meant that the two original minds that had created this had departed the field. But as is great in open source, other maintainers can step in and kind of like fill in their shoes. And I guess this is part of the work that I adopted, myself and a few other people. So my initial tasks were to port YOLOv3 over to Torch, try and improve it, make it useful, and make it more accessible, I think, for beginners like me that really had no idea what they were doing. So this was all just unfunded. It was sort of a hobby at that point in time, and Ultralytics was just down to one person, which was me. So I spent about a year getting up to speed until I could reproduce the training results in Darknet. And once I got there, I wasn't sure what to do. So I just kept going. I worked on improvements on a few different places in the code, such as the data loaders, the augmentation, the loss functions. And eventually I was producing results that were substantially better than YOLOv3 using the same exact architecture. And I had a bit of a problem explaining this to people, because I'd say, look what I did. It's getting these results, and they'd take a look at what I'd done and they say, no, Glenn, that's incorrect. You've implemented this the wrong way. You should read the paper. So I realized I should probably work on some more improvements and call this something else so I could tell people more easily what I was up to. So I worked on more improvements, and once I had, I think, a substantial lead over the YOLOv3 numbers, the accuracies and speeds, I was about to launch this and I wasn't sure what to call it. And so I decided just to call it YOLOv4. And when I was putting the finishing touches on this YOLOv4 of mine, I got a message from a colleague. I said, Glenn, if you've seen the news, YOLOv4 has been released by this guy, Alexei AB, on GitHub. And I knew him very well. We collaborated really closely. We had thrown ideas back and forth, and it looked like he had the same exact plan. He got to it before me. So Alexei was taking a different tack. He maintained the Darknet repository as is in a fork of his, and he continued to improve upon it there in C. So I read the paper and took a look at what Alexei had done. And I folded those improvements also into my own work. So I did that over the course of a few months. And then again, I had a naming problem, wasn't sure what to call it. And I decided, okay, I'll just call this V5. So I did that. There was a lot of controversy and I wasn't sure how to handle it. But ultimately I kind of ignored it and just kept doing what I'd been doing the last few years, which was just learning and improving YOLO as much as I could, and helping people use it and listening to their pain points and their bug reports so that I could improve things. And so every day I would do this 12 hours a day, 7 days a week. This was basically my life for the last few years. So YOLOv5 started gaining traction, started getting picked up, and this is when the revenue initially started coming in. So that's a bit of the history. And I think from there, got a quick agenda here. So I'm going to told you about YOLO. I'm going to tell you about Ultralytics, a few use cases people are using this for, some of the improvements in YOLOv8. So YOLOv8 is a new architecture and training framework that we've created due to breaking changes that we couldn't implement in YOLOv5 without probably interrupting a lot of people's existing workflows. So we've been accumulating these for a few years, and we decided to release an entirely new architecture, which is called YOLOv8. We did this back in January. It's got a bunch of cool new features versus V5, and I'm going to tell you about those. And ultimately, I'm also going to tell you about Hub, which is our no-code tool to make this even easier. Okay, so since those early days, YOLO's come a long way. So now Ultralytics has 3 different YOLO repos, which are YOLOv3, which is my first work, YOLOv5, and now YOLOv8. So combined, the analytics and the metrics on these are just really impressive. We get over 2 million monthly visits from students, researchers, organizations. And every day people use the Ultralytics pick package to analyze more than 20 million things, which could be pictures, videos, directories. And we train over 20,000 models every day, not us, but the users. So by the time I'm finished with this talk, hundreds of new YOLOv8 models will have been trained and starting to be deployed. So in this time, we picked up 60,000 GitHub stars also. So the team is really small. As I mentioned just a few years ago, it's just me. Now we've grown a little bit. Most of us are here in Madrid, where I am, but we also have a lot of remote people. And besides the amazing team we put together, we have about 500 contributors, which we wouldn't have been able to do what we've done. So without the open source community, without those contributions, I think we wouldn't really be here today. So we owe them a great deal of credit. I'd like to take this opportunity also to say that we're looking for talent. So if you'd like to contribute, if you used YOLO before, we'd love to talk to you. So, okay, now what are these use cases? So I'd say like the single most perplexing question that I get when I go to conferences, talk to investors, they say, Glenn, what's this good for? Like, why do people use YOLO? And if I give them a specific use case, like I'll say, you can use it for a soccer app. And then they'll say, okay, I get YOLO is good for soccer. And then I'll say, well, hold on. No, it is, but it's also good for a bunch of other things. And so we've got a few examples here, but truth be told, the potential for the technology is really endless. And I guess this is also where I should step in and kind of explain the difference between what we do and generated models. So generated models are awesome. I think we're all using them these days, whether it's text or image. But there's different use cases where you don't really need to generate anything. So for example, Amazon is using YOLO for package tracking on 5 different continents. So the technology is really being used in a lot of commercial applications. Procter & Gamble for flaw detection in factories. They need to analyze millions of images of products that they fabricate almost in real time. So there's really applications that don't lend themselves to the cloud for privacy purposes, for latency purposes, for cost purposes. So that's where these models really excel. We're on 2 different places here on a chart of, I guess, like speed and size. So generated models tend to be very large, and for that reason, they sit in the cloud, and that lends themselves also to this good business use case of startups popping up, creating kind of like a proprietary model like GPT-4 and selling access to it. So this is different. Ultralytics makes all this for free. Everybody is allowed to go to the GitHub repo, get our latest versions, and just use that however way they want, as long as they follow the license, which is GPL. So you can pretty much do anything with that as long as you open source it. And if you prefer to keep it private, then we also have enterprise licenses. And so that's how we make money now. Companies come to us. They see that it's very popular. They see that it works very well for their use case, and they'd like to embed it in their products internally or externally. And that's how we're here. So we don't have a big sales team or anything. We just have this inbound traffic of license requests. Okay, so this new YOLOv8 architecture that we launched with the new Ultralytics framework and the Ultralytics pip package. So previously, YOLOv5 was just a GitHub repo. You had to clone it and get started that way. The community came also with other solutions, most notably Fatih, who's also now on the team, created the YOLOv5 pip package unofficially and has been maintaining it. So we really appreciated those efforts, but we wanted something that was seamlessly embedded and pip package native. And this is one of the changes that we did in YOLOv8. So now YOLOv8, you just pip install Ultralytics, and this gives you access to a bunch of different models, which I'm going to talk about later, not just YOLOv8. Okay, another change that we did is we actually created useful documentation this time. So in my time at YOLOv5, I was extremely responsive. I answered about 10,000 issues over about 2 years. This gave me incredible insight into what people's problems were. And this is one of the things that allowed me to really direct the development of YOLOv5 to match what everybody wanted to see in it. And one of the things that people eternally complained about was docs. And I was very new to development, and I'd never done docs before. So for the first year, I had no idea what people were talking about. And then I started doing a little bit more homework on some other tools like Torch, and I was like, oh yeah, we could use something like this. And so for now, YOLOv8, we've done a lot of effort into the docs. The docs are just at docs.ultralytics.com. We've got about 150 pages. I think I've written about half of that myself. It's pretty exhausting, but a lot of what you need is right there, of course. And if you can't get your answers there, you're encouraged to raise an issue directly on the repo, and myself or someone from the team will get back to you. Okay, so the interface. So we've got a seamless combination here of CLI and Python API. YOLOv5 suffered from a bit of a systemic fracture there. I developed it as Python first, and then sort of CLI as kind of like an afterthought. And this meant that not all arguments were shared between them. and there's kind of like strange quirks. And so when we developed YOLOv8, we developed it from the ground up to have as much commonality as possible. So there's a single set of arguments that can be used with CLI with the API. There's no more separate hyperparameters, separate arguments, separate command line stuff. It's very unified, very simple, and very effective. And most people that have tried it tend to like it. So this is the other point, the centralized configuration. In YOLOv5, we had hyperparameter YAMLs. We had settings that you could do at the command line, and also an arc parser, which had a few settings. And I'm embarrassed to say even some hard-coded settings. So it's a bit of a mess. And we've taken all that into account. We've streamlined it, modernized it, and put this out there. So it's much, much easier. And if there's any setting that you want to look at, they are all in a single YAML. And of course, the docs explains all this also. Okay, this is the fun stuff. This is what people really want to hear about. This is the architecture updates in YOLOv8. So the first year of YOLOv5, I was really working on architecture updates. I was really motivated, you could say obsessed with bringing the speed and the accuracy up to the state-of-the-art models of the day. And the second year, which was basically last year, I was more concerned with expanding the feature set. So I wanted to write tutorials, add export formats and things like that. And this meant that I sort of took my foot off the gas for architecture R&D. And this let like a few other companies step into the space. So notably Meetup, which was a Chinese startup, but now is a rather large Chinese company, launched what's called Meetup YOLOv6. Lexi came back at it with a model called YOLOv7, and a few other organizations, probably mostly from Baidu and Paddle team, came out with advancements also. And so we scoped them all out. We cherry picked what we could improve within YOLOv8. We ran studies on, I think about 400 different model experiments. And we released this together as YOLOv5, which started from YOLOv8. So 3 of the main changes are here. So split head. Medvi was the original company to pioneer this in the YOLO model with YOLOx. And we did adopt this, not the same exact format, but a slightly different one. There's always a trade-off between speed and accuracy. And I think in this context, it made sense because the main split is between regression values, like a box or segments, and classification. And they do have different loss functions, and I think it made sense to split them. So we have splits there, and for additional tasks, like for example, if we have segmentation, then there's an additional split, and the same for pose. DFL loss is a really interesting update to bounding box regression. So we'd already been using the state-of-the-art bounding box regression criteria, which was CIOU at that point in time. And DFL, the main change here is that DFL will take multiple predictions for a bounding box and combine those together. And intuitively, this makes sense because if you combine multiple estimations that are each slightly noisy, you'll end up with a value that has some of that smoothed out. And DFL does a pretty good job of this. And it's one of the reasons for specifically better map at the higher IOU thresholds. C2 layers. So the main building blocks of the YOLO models that I put together have been C3 and YOLOv5, now C2. It's really interesting because this is optimized essentially for TensorRT, but in some other places, especially on some deployment hardware, some changes can have opposite effects. So one of the key things that we do at Ultralytics, one of the big differentiators between what we do, for example, in Hugging Face and language models, is that we are really concerned with how these perform at the edge. Our users don't want to do anything in the cloud. They don't want to, say, have to sell 1 million devices with YOLO and have them all ping the cloud and get a huge bill at the end of the month. They want the devices to be embedded on something really small. Like let's say you have a refrigerator, you want to see when the orange juice is done, order a new one. And for this reason, YOLO has to run seamlessly on all types of ASICs, edge devices. And this is what we really work hand in hand with a lot of the providers to do. So if you train a YOLO model, you can be pretty confident that it's going to work wherever you need it, be it a Raspberry Pi, Jetson Nano, or any other place. Oh my goodness. Okay. And now we have a bunch of tasks. So this is really exciting. It's something that's just happened in the last 6 months. So YOLO, of course, was born as an object detection model, and now it's expanded. Now YOLOv8 natively out of the box offers classification models, detection models, instance segmentation models, tracking, which isn't a type of model, but can be applied to detect, segment, and pose models, and pose estimation, which can be single class or multi-class. So if you want to see the pose of your dog and yourself at the same time, you can do that as long as they have the same number of key points. Okay, we also support what are called modes. So with any of those tasks, you can do any of these things. You can train a model, you can export it to almost every known format, you can validate it, you can perform tracking on some of the tasks. So the cool thing is that we offer tracking for not just detection models, but segmentation models and pose models. And you can run predictions and you can benchmark. So as I mentioned before, we're very obsessed with how these perform on edge devices, on export formats. And because of that, we have an official benchmark mode, which will take a PyTorch model, export it to every format. There's about a dozen formats, including TensorRT, Onyx, OpenVINO, Paddle, and it will profile that for speed and accuracy at any quantization that you want. So this will give you the confidence that when you take that model and you quantize it down to 16 bits or 8 bits, this will show you how much accuracy you've lost and what the speed of that will be on your hardware. Okay, and this is something that's really interesting too that most people don't know about. YOLO, now with the Ultralytics package, is not just YOLOv5 and YOLOv8, but we also support a lot of other models, and we're doing our best to take the latest models that are coming out and add support for them. So for example, SAM, which I mentioned before, you can use this directly from the Ultralytics package. And I would dare say that it's easier to use through Ultralytics than it is directly from the source. So this will auto download the model and run it on any images, or you can use it in auto label mode on a detection data set. So if you have a detection data set, like what I did with Coco was I took the detection labels, I passed it through our auto labeling using SAM, and it spit out a segment data set, of course, which is ready-made to train, again, with the Ultralytics package. So you can do this with anything. So this is really cool. Essentially now any data set that has at least common everyday items that SAM would be able to segment can now be trained in segmentation mode. So you don't need any fancy tools. You don't need to pay a lot of money to data set companies for their annotation services. You can do this yourself with just about 2 lines of code. The other models that we support are Meetup, like I mentioned, with YOLOv6. So the team's done a really good job there. They're split between Shanghai and Beijing, and they're very serious about it because they use YOLOv6 within their own delivery robots. And also RT-Deader. RT-Deader is a recent advancement out of Baidu from the Paddle team. It's really cool because it's a real-time model that has dropped the NMS that comes out of it because it's got a transformer head. And this could be really useful for YOLO also, and it's something that we are trying to mix together. No luck yet, but it's on our roadmap. Oh, okay, and lastly, Hub. So as I mentioned, we're very focused on making things simple. We want this to be as simple as possible to widen the addressable market as large as possible, to have the most number of people training models and doing amazing things with these, to really have the biggest effect on society and on the world. And Hub is the next step in that direction. Hub is a no-code tool that we've developed, that we are still developing. And this is a way to train and deploy YOLO5, YOLO8 models just with a click of a button. So as easy as I try and make YOLOv5 and YOLOv8, it can only go so far as a bunch of code. You need to be a Python person. You need to know what you're doing, setting up environments, and not everybody knows how to do that. And so this is for the rest of those people. So the way to use this is very easy. You either upload a data set that you have, or you link up with one of our partners and import a data set. And from there, you select the model you want to train. You click train, you get this back in a few minutes or a few hours, and you deploy it pretty much anywhere you want, any type of device. And it comes with a really cool app that lets you preview this right there in the palm of your hand. If you want, you can scan this QR code and check it out yourself. So this is it. I think that's the slides I had. And I think like the question I'd like to leave everybody with is what cool tools and what kind of cool solutions we can all build with this. I've taken it upon myself to make it as easy as possible. Ultralytics doesn't offer any dedicated solutions, but it's really the community and everybody that uses our models that creates amazing stuff. So.
Cool. Awesome, Glenn. Well, it does look like you have a few questions in the queue if you want to jump in there and work through them.
Oh yeah, wow, I just noticed this. Okay, let me take a look. Uh, okay, let me just start at the top. Glenn, is the detection performance speed noticeably faster or better for custom data sets? Person only between YOLOv4, 5, or 8? Yes. So Cocoa dataset is one thing. There are some other data sets and there's one data set put out by RoboFlow, which is a combination of other data sets. And V8 does a much better job than V5. But an interesting thing too is that these models are not static. So whatever results V8 gets initially is just like V5, but it's going to change over time. And so the plan is to release updates, 8.1, 8.2, and so on and so forth. So we're in the middle of some R&D right now for those 8.1 models. Let's see, second one here, quick question. What is more preferable while segmenting small objects, box annotations or polygon annotations? There's very small objects can be visualized as just a bunch of annotation points. Yeah, okay, so this is a good question. The small objects, there's a lot of tricks people can try, but ultimately you can't really escape the fact that you just don't have a lot of pixels to work with. And so your signal to noise is going to be higher for these. And the one unfailing method to improve small object detection is to use larger image sizes. We do have a specialized model for small objects, which is a P2 model, which goes all the way down to P2, which has a stride of 4. And this is going to produce better results for those small objects also. All right, let's see, second one. Glenn, can we ensemble different YOLO models? Okay, yeah. Ensembling, interestingly, is when I first got into AI, this seemed to be something that I definitely needed to do. And so I spent a lot of time in V5 importing that and making it super easy to use. But ultimately, I think ensembling doesn't have too many real world applications. I think it may be more of a method to kind of squeak out the very best results in maybe a Kaggle competition or for a paper. I think the cost trade-off analysis just isn't there when you look at the extra flops that are required to kind of like get that last small bump. And you could probably do a better job with a single larger model, or at least a better compromise. So that being said, V8 does have ensembling for, I think, detection. So if you want to use it, it's there. Okay, let's see. Part says, hey, I want to create a computer vision model which has good speed and accuracy. I was thinking about ensembling. Okay, V8 and RedNet. Okay, so the trick with ensembling, there's different types. We do the simplest type by default. The other types are commented. But what we do is if you have two YOLOv8 models, or let's say YOLOv5 and YOLOv8 model, we'll take those detections prior to NMS and just bunch them together. And then we'll throw that at NMS and let NMS sort it out. But this does mean that your models have to have the exact same classes. And in the case of RetinaNet, you might run into problems due to the output format. So if you create a wrapper around RetinaNet to output those in the same format, everything should be fine. But again, the two models need to be trained on the same data set. So Cocoa YOLOv8, Cocoa RetinaNet, you should be fine. Okay, let's see. Matiko says, hi, Glenn. YOLOv8 sounds really interesting. Is it possible to use YOLOv8 with other programming languages besides Python? Oh, with C, okay. This is interesting. So a lot of people choose C for deployment. C is a little complicated for my tastes, but it is faster. And a lot of people prefer, for example, a TensorRT export. They prefer to run that natively with C rather than use Python. So one thing I forgot to mention is that every export format, we also support inference for. So if you export to TensorRT or Onyx, you can use the YOLO pip package to import that model and run it the exact same way. Instead of passing the PyTorch model, you just pass the TensorRT model or Onyx model. So we made it very, very easy. But again, some people prefer to kind of strip all that away, just use the pure Onyx model on a CPU or the pure TensorRT model with C, C++. And we do have some examples of how to do that in the repo. We've got an examples directory, and I haven't written anything there, but we do have contributors that have provided examples. And I think one of those is for C++ inference. Training, no, though. For training, I would not recommend straying away from PyTorch. Okay, Sakshi says, what line of thinking inspired you to make changes to the quite successful architecture? They did not use anchor boxes in V8. Oh, okay, this is really interesting. Yeah, it's kind of sad because I spent a lot of effort and lost a lot of sleepless nights figuring out these anchor boxes in YOLOv5. So an anchor box is really just a funny word for a way to normalize an output. When you train a model, you want the range of values that it's trying to predict to be similar. So for example, if it's outputting, say, two different things, and one of them has a range of -100 to 100, and the other one goes from -1 to 1, it's going to be very problematic for the model. And so since YOLO is classifying things with a sigma wave from 0 to 1, but it's also regressing these boxes, and the boxes can be really big. If you have like a 4K image that can be 4,000 pixels wide, you still divide that by the stride, but still we had this normalization problem. And so Joseph and company decided to create these normalizations and call them anchor boxes. And so this means that the model would output different predictions, assuming different normalizations. And they got this to work. And so this meant that using more anchor boxes would create better results. But it also meant that there were more outputs for the model. It would take longer to run NMS. And ultimately removing those was the best solution. And I didn't come up with this idea. I can't claim credit for this. But we'd seen other architectures do it, and we chose to adopt that also. So with YOLOv5, we had this really cool hyperparameter optimization and also bounding box genetic evolution algorithm that I came up with. And we threw all that away for YOLOv8. So it's simpler, it's easier, and it gets better results. So let's see. Oh yeah, the tracking. I forgot to mention that we integrate the latest SOTA trackers. We've got two of them, byte track and bot sort. And if you want to bring your own tracker, you can do that also. So let's see, YOLOv8 plus byte track. Do you this is a better combination, or do you suggest anything else for tracking instead of byte track? Oh, wow. Okay. I think like what we have as a default is very good, but obviously there's always improvements that you could make to it. The other thing is that tracking is going to depend on the quality of the detections. So as the model produces better detections, the quality of the tracking and the re-identification will also improve. So you can attack that from those two different sides. Oh, okay. Got through it all.
Yeah,
I hope nobody fell asleep. That's all. Yeah.
Yeah, that's it. So if you want to kill your share, we'll wrap things up here. So a big thank you, virtual round of applause here for Glenn, Eric, Jerome, Narik, as well as Mikhail. Hopefully you appreciated and enjoyed all of the talks. Let me do a quick screen share here so we can close things up. All right, so once again, if you have not already done so, please make sure to head on over to the charitable giving page and vote for a charity that speaks to you. Let me go ahead and post those links there again. And if you have time and you enjoy our work here at Voxel 51, make sure to give the project a star. As I mentioned, we got a lot of exciting events that are planned up here in the next 30 days or so. We have a getting started workshop. We have a Voxel GPT, how it was built webinar, but then also on July 13th, don't forget, we have the special vector search themed meetup where we'll have speakers from Zills, Milvis, Quadrant. We'll do presentations on Pinecone. We'll have Quadrant as well as LanceDB. So lots of good stuff is happening there. And let me just go ahead and post the links there if you want to check out the Zoom registration pages for that. So once again, thank you very much for taking time out of your busy day to join us here. Lots of good stuff. It's hard to cram it in all within time, but hopefully you found it useful. And again, thanks to our speakers, Glenn, Eric, Jerome, Narik, as well as Michael. And don't be shy. If you have an interesting story to tell in regards to computer vision, please consider speaking at a future meetup. So we'll go ahead and leave the webinar open for another minute or so if anyone has any burning questions, but otherwise, thanks again, everyone, and we hope to see you at an event soon. Thanks, everyone.
Thank you, guys. Bye.
Thank you.
Thanks, everyone. Bye.